All right, number 20 is an excellent example of why near the end of these sections, as you're running out of time, don't just go in the order that the questions are presented and run out of time before number 20. Just because number 20 is at the end doesn't necessarily mean it's going to be the hardest for you. In fact, I think this is a great example where if you had skipped number 19, you could have easily picked up 10 points with this number 20. It's not that bad. And that's because that we're going to use an important strategy here. Get back to basics. And remember, this is our strategy to just kind of ground us whenever things get a little wacky. And so there's a lot of stuff that looks scary, and there's pi over 3. We're talking about circumference, length of an arc. Especially if you hated geometry in school, this looks scary, but it's not. So to me, when I think get back to basics, that means write down whatever formulas come to mind for a particular question. Even if you don't know how you're going to use them yet, write them down. And there's one formula in particular that I know is going to come in handy whenever I'm talking about fractions of circles, and that is part over whole. Now in school, you probably learned a separate formula for the area of a sector, for the arc length of a sector, for the degree measure of a sector, probably all these crazy things. But in reality, they're all really just one formula that represents a fraction, because a fourth of a circle contains a fourth of the area, a fourth of the arc length, a fourth of the degrees, a fourth of the radians. So we're going to use the fact that that fraction is consistent to our advantage. So what we really need to do is understand how this circle's whole is divided in this particular case into a part. So we are concerned with an arc AB that would be somewhere out here. So let's highlight it. It would be this outside arc here. So that's the part of the circle that we are concerned with. And we're just going to put what we know on the picture, because why not? We know that that is pi over 3, and we know that the radius of the circle is 1. And notice we didn't get this picture, we had to draw it. It's very rare for the SAT to make us draw the picture, but if it's a geometry question without a picture, they're trying to trick you. Draw the picture. Get it out of your brain and onto the page, and I promise it'll be easier to understand. So how are we going to use this part over whole? Well, I know the part. The part that I care about is this pi over 3. That's the part. So that's the top of my fraction. So I need to understand, okay, well, if that's the part, it's the part of what? Part of what aspect of this circle? What's the whole that goes with it? Well, they're kind of telling us in the question that it's the circumference. And we should probably know that, because if we have an arc length, then the whole way around is the circumference. So if we're going part of the way around a circle, that's an arc. If we go the whole way around, that's called a circumference. And we're going to use the circumference formula to get the bottom of this fraction. Hopefully you have that memorized. But if not, at least remember that if you go back to the front of the test, they include all of these wonderful geometry formulas, and one of them is the circumference of a circle, 2 pi r. So let's write that on our page so we don't get confused. Circumference is 2 pi r. And in this case, we know that the radius is 1. They told us that. So we know that the circumference is just 2 pi. So the entire circle, the whole way around, is 2 pi. And again, this looks scarier than it is. This is now just understanding how fractions within fractions work. So I would just need to reduce this. And what I would do is I like to have 2 fractions. If I'm dividing a fraction by a fraction, it's easier if they're 2. And then I use something called keep, change, flip to divide 2 fractions. So how does that work? We keep the top fraction as is, so that's pi over 3. We change the division, that's what the fraction means, we change the division to multiplication, and we flip the bottom fraction upside down. So that's 1 over 2 pi. So now we've just got to do some multiplication, and it's easy because the pi's are going to cancel. And really now we just have 1 on the top, and 3 times 2 is 6 on the bottom. So that is the fraction. You could bubble that as a decimal if you really want to, but it's easier as a fraction. And so this is going to work whether we were asked about the arc length, whether we were asked about the area, the number of degrees. We could use this part over whole idea for all sorts of things because it's consistent. And a lot of times when we do this, we actually set up two equations, two part over whole equations, two ratios next to each other. But that is not necessary for this one because all they care about is the actual fraction itself. So try to skip ahead and get this. I think this is an easier question than number 19. So get those points first.